Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2013, and let's get started. First problem, square ABCD has length 10, point E is on BC, and the area of ABE is 40, what is BE? Okay, so we know that this is 10, and the area is 40, therefore BE must be 8, that's the answer, it's E. Number 2, a softball team played 10 games, scoring 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 runs. They lost by 1 run, exactly 5 games. In each of the other games, they scored twice as many runs as their opponent. How many total runs did their opponent score? Okay, so if they scored twice as many runs as their opponent, that means they scored an even number of runs. Yeah, but then since they lost in 5 games, that means that they won in 5 games also. And there are only 5 games with even number of runs. That means those are all the games that they won, right? So they won. Those are 2, 4, 6, 8, 10 runs. And the ones that they lost are the ones with 1, 3, 5, 7, 9 runs. And this is going to give us, that their opponent scored half of these. So it's 1, 2, 3, 4, 5. And for here, their opponent scored one more than that, which is 2, 4, 6, 8, 10, right? So if you add these all together, this is 15, this is 30. That gives us 45. And that's the answer. It's C. Number 3, a flower bouquet contains pink roses, red roses, pink carnations, and red carnations. 1/3 of the pink flowers are roses, 3/4 of the red flowers are carnations, and 6/10 of the flowers are pink. Or what percent of the flowers are carnations? Okay, so if we classify them by color and type, then that's going to give us, let's say this is pink and red, or roses and carnations. Let's say we have A, pink roses, and B, red roses, and 1/3 pink flowers are roses, so that will be 2A, and 3/4 are carnations, so this will be 3B, and 6/10 of the flowers are pink. That means 3A over everything. 3A plus 4B is 6/10, so that's 3 over 5, right? So this gives us that A equals 2 and B equals 1, because that way if A is 1, B will be 1/2, and then that would just be equal to A being 2 and B being 1. And so we want what percent of the flowers are carnations, so that's 2A plus 3B over the whole thing, 3A plus 4B, and if we plug these in, then we are going to get 7 over 10, that's 70%. So 70% is our answer, it's E. Number 4, what is the value of this thing? Okay, so we can just divide by 2 to the 2012th power, and we will just get 2 to the, 2 squared plus 1 over 2 squared minus 1, which is just 5 over 3, and that's our answer, it's C. Number 5, Tom, Dorothy, and Sammy went on a vacation and agreed to split the cost evenly. During the trip, Tom paid $105, Dorothy paid $125, and Sammy paid $175. In order to share the cost equally, Tom gave Sammy $T and Dorothy gave Sammy $D. What is T minus D? Okay, so if they shared the cost equally, then each person would pay $135, right? We can just get that since the hundreds and ones digits are the same, so we can just look at the tens digit and find that the tens digit has to be 3. And so for that, Tom would have to pay $30. So Tom would have to pay $30, T equals 30, and Dorothy would have to pay $10, right? D equals 10. So T minus D, it's 20. That's the answer, it's B. Number 6, in a recent basketball game, Chanel attempted only 3-point shots and 2-point shots. She was successful on 20% of her 3-point shots and 30% of her 2-point shots. Chanel attempted 30 shots. How many points did she score? Okay, so gave us no clues as to how many 3 points and how many 2 points that Chanel might have scored. And so that means it doesn't matter. Let's say that she tried 10 3-points and 22 points. This gives us 2 times 3 plus 6 times 2. That gives us 18. So 18 is the answer, it's B. Number 7, the sequence S1, S2, S3 all the way to S10 has the property that every term beginning with the third is the sum of the previous two. Okay, so what this basically gives us is this is like a Fibonacci sequence. Fibonacci sequence. If we have terms starting with S4 all the way to 6, 7, 4, 5, 6, 7, 8, 9, 10. Right, so 8, 9. We know that S9 is 110, and S7 is 42. So 42 plus this is 110. That gives us that the middle term is 68. And for these two to sum to 68, that means it's 26. For these two to sum to 42, that will be 16. For these two to sum to 26, that will be 10. So 10 is our answer. It's C. Number 8, given that x and y are distinct non-zero real numbers such that this holds true, what is xy? Okay, so if we move that here and move this here, then that would basically give us that x minus y equals 2 times 1 over y minus 1 over x. That equals 2 times xy, all under x minus y. And so if we just cancel these out, then we get xy equals 2, and that's our answer. It's 2. It's D. Number 9, in triangle ABC, AB equals AC equals 28 and BC equals 20. Points D, E, and F are sides AB, BC, and AC respectively, such that D, E, and EF are parallel to AC and AB respectively. What is the perimeter of parallelogram ADEF? Okay, so the first thing that we can notice is that these two lengths are equal, right? DE and DB, and same thing for here, FE and FC are equal. That means this length, right, that's the perimeter, that's just equal to this length plus this length. And AB equals AC equals 28, so we can do 28 plus 28 equals 56, and that's just our answer, right? So it's 56. Number 10, let S be the set of positive integers n for which 1 over n has the repeating decimal representation 0.ab bar, 0.ab, ab, ab, like that, with a and b different digits. What is the sum of the elements of S? Okay, so since this is base 10, we know that 0.ab is something that's ab over 99, right? And a and b have to be different digits, and so this, for this to be in 1 over n form, that means ab can be 0.1 or 0.3 or 0.9 and nothing else. And here n would be equal to 99 because it's 1 over 99, like that. And here it's 3 over 99, which simplifies to 1 over 33. That means n equals 33. And same thing for here, we get that n equals 11. So if we just add these all together, that gives us 143, and that's our answer. It's D. Number 11, triangle ABC is equilateral with AB equals 1. E and G are on AC and D and F are on AB, such that both DE and FG are parallel to BC. Furthermore, triangle ADE and trapezoids DFGE and FBCG all have the same perimeter. What is DE plus FG? Okay, so we need to focus on the same perimeter thing, because first of all, let's look at these two trapezoids, right? If we put altitudes from there, like that, right angles, and like that, right angles, like that, right? Then we can see that for this one and this one, they share this line, so we don't have to worry about that being in the perimeter. And for this line, that's equal to this much. And so for the perimeters to be equal, that means this must equal this, and this must equal this. But then since we know that it's an equilateral triangle, we know that this is 60 degrees. And so if we say that this is length 1, right, this is length 1, then this means this is length 2. Same thing, this is 60 degrees, so if we say this is A, then this is A also, and this is 2A. But then we just said that this has to be equal to these two added together. So 2A equals 3 plus A, 2A equals 3 plus A, that means just A equals 3. A equals 3. And so these A's can go away, and A is equal to 3. So this is 3, this is 3, and this is 6. And now let's look at this one and those ones. And we know that just this is the same, and for this one we can see that it's this much because those are the same and those are the same. And so that means this one EA must account for both this and this, right? Since it's equilateral, it's symmetrical. And so we know that this must be 6, this must be 3, and same thing, 2, 1, 3, like that. And so now we get that this one must equal this plus this. And this plus this is just 9 plus 9, which is 18. So we just get that this is equal to 18. So that's 18. What is DE plus FG? Okay, so DE, that's 18, and FG, that's 18 plus 3 plus 3. So DE plus FG, that is going to be equal to 18 plus 3 times 2, that's 42, right? This is 42, but then it said that AB equals 1. And so in actuality, so one side of the large equilateral triangle just equals 1. And so since we said that this was 26, 26 must equal 1, that means we have to divide by 26. So we have to divide by 26. Same thing for here, we have to divide by 26. So it's 42 over 26, which then simplifies to 21 over 13, and there's our answer. Number C. Number 12, the angles in a particular triangle are in arithmetic progression, and the side lengths are 4, 5, and x. The sum of the possible values of x equals a plus root b plus root c, where a, b, and c are positive integers. What is a plus b plus c? Okay, so if the angles are in arithmetic progression, that means one of the angles, since the angles sum to 180, that means one angle is 60 degrees for sure. But then we don't know where that 60 degrees is, and that's where we have our multiple values of x. So if we have 4, 5, and x, and let's say this is the 60 degree angle, then if we have an altitude like that, then this will be 2, and this would be 3, and this would be 2 root 3, right? So x is going to be equal to root of 3 squared plus 2 root 3 squared, that's 12. This is going to be equal to root 21. And so x is root 21 in this case, or it could be the case that, or the 60-degree angle could be over here, right? That could be 60 degrees, and we could just do the same thing, drop the altitude, and here would be 2, and here would be 2 root 3, and we can know this angle because this is also a right triangle. So by Pythagoras, this gives us root 25 minus 12, that's root 13. So x is equal to 2 plus root 13 also, because this is 2 and this is root 13, and they make up x. Lastly, let's look at the case where this is 60 degrees. If we do that, right? If we do that, then that's going to give us, this much is going to be, I'll erase this now. This much is going to be 5 over 2, and this much, that's going to be 5 root 3 over 2, and then 4, not that 2 here. Then this would have to be root, and then 16 minus 75 over 4, which is a negative angle. So this is root of like a negative number, which cannot exist. So this is just not possible. So these are all our values for x. And so if we add them together, it's 2 plus root 13 plus root 21. This gives us 2 plus 13 plus 21 equals 36. And that's our answer. It's A. Problem number 13. Let points A equal 0, 0, B equal 1, 2, C is 3, 3, and D is 4, 0. Quadrilateral ABCD is cut into equal area pieces by a line passing through A. This line intersects CD at point P over Q, R over S, where these fractions are in lowest terms. What is P plus Q plus R plus S? Okay, so if we have a grid like this, if we have a smaller grid, this one, and let's say that this is the origin. This is 0, 0, this is A, and B would be 1, 2, so B would be over here, and C is 3, 3, and D is 4, 0, like that. And by a line passing through A, and so we have the quadrilateral, that will be something like this, right? That would look like this, and that would go through, and there will be a line going through that, like that, and it intersects CD at point P over Q, R over S, so that's this point right here, and the fraction should be in lowest terms. Okay, so basically what we need to get here is the area of ABCD. This is D, and so the area, that's just gonna be, if we move this much to be here, then that's gonna be this much plus 1.5, so that's 7.5, which is 15 over 2. But then for area to be halved, because it's cut into equal pieces, that means that halved, that is going to be 15 over 4. But then that's going to be this area, because this one cuts it in half, so this area is going to be 15 over 4. And since the base is 4, that means the height must be, this is 1/2 times base is 4 times height. So the height is 15 over 8. So that gives us R over S. R over S is 15 over 8. R over S. And next we have to get this value. So to get that, we need this one and this one. And since we know just the y value of that, we just can need this one. So CD, that is equal to, CD, this is equal to y equals minus 3x plus 12. And if we put in y equals 15 over 8, then 15 over 8 equals minus 3x plus 12. 3x equals 12 minus 15 over 8. X equals all over 24, and 96 minus 15, this is 81 over 24, which is 27 over 8, right? And so this is our x value, that is P over Q, right? So we have RS and PQ. If we add them all together, it's 15 plus 8 plus 27 plus 8, which is 58, and that's our answer. It's B. Number 14, the sequence, this is an arithmetic progression. What is x? Okay, so for logs to be arithmetic progression, that means the stuff inside the logs has to be in a geometric progression, right? And so that basically means that if we get 162 factorized and 1250 factorized, then we will be able to see by how much it's changing each time. 162, this is equal to 2 times 3 to the 4th power, that's 81 times 2, and 1250, it's 2 times 5 to the fourth power, right? Basically, we see that each time we are taking away a 3 and adding a 4, and that is going to eventually lead to 2 times 5 to the fourth power. So that means every time do and then multiply by 5 and divide by 3, which is just multiplying by 5 over 3. 5 over 3. And so x, that's just going to be 162 times 1 of that. So 162 times 5 over 3 equals, that equals 270. And there's our answer. It's B. Number 15. Rabbits Peter and Pauline have 3 offspring, Flopsy, Mopsy, and Cottontail. These 5 rabbits are to be distributed to 4 different pet stores so that no store gets both a parent and a child. It is not required that every store gets a rabbit. In how many different ways can this be done? Okay, so first, if they are to be distributed to the pet stores in 1, 1, 1, 2, because this is the maximum number that they can be distributed into, then we are going to have 4 times 4 factorial times 4 possibilities, because this 4 is that 4 is for which one is going to go in this 2, right? So we can have the Peter and Pauline go in there, or we can have any 2 of these 3 go in there, so that's 4 possibilities. And for factorial, this is just choosing which pet store will each one go to. And so this is going to be 4 times 24. Next, we can have 1, 1, 3, like that. And so 3 can go together, and 1 can go separately. The only way to do that is for these 3 to be this Flopsy, Mopsy, and Cottontail. So that's only one way, times, and then same thing, number of pet stores, so that's just 4p3. So this is just 1 times, and then 2 times 3 times 4, 2 times 3 times 4, and 1, 2, 2, that's also possible. 1, 2, 2. Obviously, Peter and Pauline, they will have to be together since no store should get both a parent and a child. And so one of these should be Peter and Pauline, and the other should be Flopsy, Mopsy, and Cottontail, and this one is one of Flopsy, Mopsy, and Cottontail, right? And so we have to choose which one of Flopsy, Mopsy, and Cottontail would be that one, and then we will just get all the combinations. So that's just 3 possibilities. Multiplied by, there's 3 groups, so it's 4p3. And lastly, we have 2 and 3, because we can have Peter and Pauline go, and Flopsy, Mopsy, and Cottontail go as 1. And so that's just one possibility. 1 times in the 4p2 for distributing it. So this is 3 times 2 times 3 times 4, which is 24. And this is just equal to 12. And 2 times 3 times 4, that's just 24. These give us, so we have to add these up. That gives us 8 times 24. This is 192. So 12 plus 192 gives us 204. And that's our answer. It's D. Number 16. A, B, C are 3 piles of rocks. The mean weight of the rocks in A is 40 pounds. The mean weight of the rocks in B is 50 pounds. The mean weight of the rocks in the combined piles A and B is 43 pounds. And the mean weight of the rocks in the combined piles A and C is 44 pounds. What is the greatest possible integer value for the mean in the pounds of rocks in the combined piles B and C? Okay, so we have piles A, B, and C. Let's say A is 40 pounds times, let's say that there are A rocks in A. Let's say there are B rocks in B, so it would be 50 times B. And let's say that the mean weight of the rocks in C is X, and let's say that there are C of those, right? And so these would be the total weights. And first thing is that A and B combined, 43 pounds as their mean. So 43 equals 40A plus 50B over A plus B. This gives us that 43A plus 43B equals 40A plus 50B. And simplifying, we get that 3A equals 7B. So here we can just say that A equals 7 and B equals 3. But keep in mind, this is just a ratio. Now we can get on to B and C. And the next for A and C, that's 44 pounds. Let's say, and we said that A is 7, B is 3, so we can just substitute that. So A is 7, B is 3, and so getting that will be 40 times 7, that's 280, plus, and then X is C, right, all over 7 plus C. This is going to be equal to 44, and this gives us that 280 plus XC equals 308 plus 44C. This gives us that 28 equals X minus 44, X minus 44C. So we have this equation. And then lastly, we have B and C, and that's what we want. B and C, that's going to give us 150 plus CX over, and then 3 plus C. But then our biggest answer choice is 59, so if 59 works, then that's the answer. So let's say that this is 59. It is 59, and we are testing this. Right, this is a test. So if this works out, then 59 is the answer. So this gives us that 150 plus cx equals 177 plus 59c. So this gives us that c times x minus 59 is equal to 27. So if we get those two together, that gives us that 1 over c is equal to x minus 44 over 28, also equal to x minus 59 over 27. So this is going to give us that if we cross multiply, then 27 x minus 44 equals 28 x minus 59. So x equals 28 times 59 minus 27 times 44. So this is going to give us 1652 minus 1188. That is 464. So this is x. And if 464 equals x, that means c must equal 1 over 15. And you might say that, oh no, this is a fraction. That's impossible because c has to be a number. But then keep in mind that this is based on 7 and 3. But then 7 and 3, they were just ratios. And so what if this number actually was 7 times 15? And what if this number was 3 times 15? 45. That means this would just be 1. So that does make sense. So it's possible. So 59 is possible. Possible. Not optional. Possible. And so 59 is our answer. It's E. Number 17. A group of 12 pirates agreed to divide a treasure chest of gold coins among themselves as follows. The Kth pirate, to take a share, takes k over 12 of the coins that remain in the chest. The number of coins initially in the chest is the smallest number for which this arrangement will allow each pirate to receive a positive whole number of coins. How many coins does the 12th pirate receive? Okay, so for the Kth pirate to take a share, k over 12 of the coins, that means the first pirate will take 1 over 12. The second pirate will take, there's 11 over 12 left over, so that times 2 over 12. Third will take 11 over 12 times 10 over 12, that's what's left. And then of that, it's taking 3 over 12, right? And then all the way to the 12th pirate, that will just be 11 over 12 times 10 over 12 times 9 over 12, 8 over 12, 7 over 12, 6 over 12, 5 over 12, 4 over 12, 3 over 12, 2 over 12 times 1 over 12. That will be the amount that's left over, and then multiply that by it's the 12th pirate, so it's 12 over 12. And so this much is the number of coins. That's the fraction of, so that's the fraction that the 12th pirate receives. It's the smallest number for which this arrangement will allow each pirate to receive a positive whole number of coins. That just means that we can just care about the numerator when it's simplified, right? So we can simplify this and then we can get the numerator, and that's going to be our answer, right? So now we'll get to simplifying. Of course, these two are gone, and then that's gone, and then 3 and 4, that's gone. 2 and 6, that's also gone. 4, 8, that's gone. That leaves 3. And 4, 9, that leaves 2, right? Because we count the 2 left over from that 8. And 10, we do that, it's 5. And that's basically it. So we have 11, 5, 7, and 5 left over. So those multiplied is 77 times 25. That equals 1925. And that's our answer. It's D. Number 18. 6 spheres of radius 1 are positioned so that their centers are at the vertices of a regular hexagon of side length 2. The 6 spheres are internally tangent to a larger sphere whose center is the center of the hexagon. An 8th sphere is externally tangent to the 6 smaller spheres and internally tangent to the larger sphere. What is the radius of this 8th sphere? Okay, so basically we can draw a top view and a bottom view of this. If we look at the top view, so that's just be the 6 spheres of radius 1. So that's going to look something like this. So these are going to 6 spheres, and this is each going to be radius 1. Since this connecting their centers, that would give us a regular hexagon. That means from the center, this much is exactly 2. And since the radius is 1, that means the full radius, that will be 3. So the radius of the big thing will be 3. So that's what we know now. This is 3. If we have a side view with the larger sphere, it looks something like this. Since we know that this much is 3, then we can have the center of this circle and then put it upward. So that would be the center. And then if we connect the midpoints, it will look something like that. And let's say that this much, that's r, right? If that's r, then that's 3 minus r. And this much, that will be r plus 1, because this radius is 1, and this radius is r, so that's r plus 1. R plus 1. This much, this is, this much is 3, but this much is 1, so that's just 2. So this is 2, and now we can use this Pythagoras. We have a right triangle with r plus 1, 3 minus r, and 2. So this gives us that r plus 1 squared, so r squared plus 2r plus 1 equals 4 plus r squared minus 6r plus 9. So these two are cancelled, and so 8r equals 12. That leaves r equals 3 over 2. And so that's the radius of the 8th sphere. It's B. Number 19, in triangle ABC, AB equals 86 and AC equals 97. A circle with center A and radius AB intersects BC at points B and X. Moreover, BX and CX have integer lengths. What is BC? Okay, so if we bring out the triangle here, right, then that's going to look something like this. This is A, this is B, and this is C. AB is 86, and AC is 97, and these lines, they are, so this is just the altitude, so that's going to be the altitude, and since this and this must be the same, this is 86, that's 86. So we have a circle with center A and radius AB, and so that circle would look like this, because it has the center at A. Now we know that this is the radius, that's why it connects to, so that's why this point is tangent. And bx and cx have integer lengths, so this point is x. And what is BC? Okay, so we want BC lengths, and basically we can just see that if we set lengths as A, and B, because A are the same, then we can just use Pythagoras for, so we can use Pythagoras for this triangle, that small one, and this large triangle, because they are both 90 degrees. So if we do that, then we get that 86 squared minus a squared equals 97 squared minus a plus b squared. So this gives us that 86 squared equals 97 squared minus, and then 2ab plus b squared. And so 2ab plus b squared equals 97 squared minus 86 squared equals 97 minus 86, that's 11 times, and then 97 plus 86, that's 183. So this is equal to b times 2a plus b. This is equal to 11 times 183. And for this to be an even number more than b, then that means b should be 33 times 61. So that means b equals 31, and 2a plus b, that would equal 61. So 61 is our answer, it's D. Problem number 20. Let S be the set 1, 2, 3, all up to 19. For A and B is within S, define A to this B to mean that either A minus B is between 0 and 9, or B minus A is greater than 9. How many ordered triples x, y, z of elements of S have the property that x this y this z, and z this x? Okay, so first of all, we can say that our only possible ways is that, so the only possible is z minus y is between 1 and 9. And y minus x is between 1 and 9, and therefore z minus x is greater than 9. That's this one. Same thing, but 1, y minus x, 9, and same thing for x and z, x minus z, 9, and y minus z is greater than 9. And lastly, we can see that 1, and then x minus z, so x minus z is between 1 and 9, and z minus y is between 1 and 9, and then x minus y is greater than 9. From this, we get that what this basically means is that x, y, z, like that. This means that z is the smallest, and then x, and then y. And this means that y is the smallest, and then z is next, and then x is the biggest. And so for here, we can just see that if we get just the number of possibilities for one of these, then that's just the same for the other two, because this is just like cycling around. It's just rotations. And so if we just get 1 and then multiply it by 3, that's our answer. So let's just go with this first case. This is going to give us, so what this basically means is that y can be 1 up to 9 greater than x, and z can be 1 up to 9 greater than y. This is just basically 9 choices, and this is just 9 choices. Or if y chooses to be 1 to 8, then this is 8 choices and 8 choices, or 7 and 7 choices, or 6 and 6 choices, like that. So that is going to give us, the sum is going to be 9 squared plus 8 squared plus 7 squared plus 6 squared, all the way up to 1 squared. And so if we just add this up, this is going to be 81 plus 64 plus 49 plus 36 plus 25 plus 16 plus 9 plus 4 plus 1, which is just equal to 285. And so this is the number for this one. And if we just multiply that by 3, that's the answer. So 285 multiplied by 3, that is equal to 855. And that's our answer. It's B. Number 21. Consider A equals this monstrosity. Which of the following intervals contains a? Okay, so the answer choices are in like log something, and so like for example, if it's log 2016 to log 2017, that's just going to mean that this much is between 3 and 4. So we don't really have to care about this because that's just kind of like a given. So we just need to care about this much, log 2012 all the way up to the end. First thing, we know that this is greater than 3 because log of 2012, that's already greater than log of 1000, which is 3. So it's at least 3, and that's shown by the answer choices here. And now we will see if this is less than 4 or greater than 4. And so for this whole thing to be greater than 4, that means that 2012, this thing must be greater than 10,000, because log of 10,000, this must be 4. And so that means that for this thing, that must be greater than 10,000. That means that this must be greater than 7,988. So this must be greater than 7,988. And so since this is the log of something, that means this value that's inside that must be, so this must be greater than 10 to the 7,988th power. And do you think that's plausible? No. That is definitely not plausible. So that's always going to be less than 7,988. So this is less than 10 to the 7,988. So this is less than 4. So that means this much is less than 4. And so this is between 3 and 4. So this much is between 3 and 4. So it's between log 2016 and 2017. That's our answer. It's A. Number 22, a palindrome is a non-negative integer number that reads the same forwards and backwards when written in base 10 with no leading zeros. A 6-digit palindrome. N is chosen uniformly at random. What is the probability that n over 11 is also a palindrome? Okay, so a 6-digit palindrome, that's going to read something like A, B, C, C, B, A. And so A cannot be 0, and B can be 0 to 9, C can be 0 to 9. So the total possibilities is 9 times 10 times 10, that's 900. So this is 900. For n over 11 to also be a palindrome, let's say that this palindrome, this is like x, y, z, y, x, right? Then that means n is going to be equal to x, y, z, y, x times 11, and that's just going to look something like x, y, z, y, x, x, y, z, y, x. That's going to be x and x plus y plus z, y plus z, and x plus y and x. And so this is a palindrome only if x plus y is less than 10, right? So it doesn't carry over, and y plus z is less than 10, so it also doesn't carry over, right? These two, and then plus we need to consider the fact that x is the leading digit, so x cannot be 0. Like now we can see if y is equal to 0, then we can have 9 choices for x and 10 choices for z. And so that's going to be 9 times 10. And if y equals 1, then this is going to be 8 choices. This is going to have 9 choices, so that's 8 times 9. And if y is equal to 2, then we're going to have this is 8, and this is 7 choices. So that's going to be 8 times 7, 7 times 8, and so on. And then 6 times 7, 5 times 6, 4 times 5, 3 times 4, 2 times 3, and 1 times 2, so that's just 2. And so if we just calculate all of these, that's going to be 90, and 72, and then 56, and then 42, and then 30, and then 20, and then 12, and then 6, and then 2. And so now if we just add all of these together, this is going to make 20, this is going to make 50, that's going to make 170. So now if we add 90 and 170, that's going to be 260. This much is going to be 70. So if we add them all together, that's 330. And that's our final possibilities. So what we have to do is 330 over 900. That should be 900, like that. So 330 over 900, that is equal to, if we cancel out, that's going to be 11 over 30. And that's our answer. It's E. Number 23, ABCD is a square of sine length root 3 plus 1. Point P is on AC such that AP is equal to root 2. The square region bounded by ABCD is rotated 90 degrees counterclockwise with center P, sweeping out a region whose area is 1 over C, A pi plus B, where A, B, and C are positive integers, and GCD of A, B, C is equal to 1. What is A plus B plus C? Okay, so if we have square ABCD like this, this is the square with sine length 3 plus 1, and for AP to be root 2, that means AP is going to be like right here. Yeah, so this is going to be P, and then if we have A, B, C, D like that, AP is root 2, that means this length is root 2, that means this is 1 and 1. So this is basically where we have 1 and then we have root 3, and it's going to be where those lines intersect. That's going to be P, right? And then it's rotated 90 degrees counterclockwise with center P, sweeping out a region whose area is 1 over C times A pi plus B. Okay, so we are going to rotate that whole thing counterclockwise like that. And so if we draw something like, and so if we have, so this is going to be our rotated square. That's gonna look something like this. That's C, and then A is this part over here, and B is this one over here, like that, right? It's going to sweep out a region whose area is 1 over C times A pi plus B. Now we can get the actual location of P. P is going to be right over here, so that's going to be P. If we have lines like this and lines like that, and then we are going to see that this equals 1, right? So this is 1, root 3, and this is equal to 1. Like that, this much is equal to 1. So now if we rotate this, then we are going to see that we are going to have like arcs like that, and arcs that go from here up to here, right? So like that. But then we don't care about this much, so we'll just look at that much. And same thing for here to here, we're just going to look at this much and go like that. And so if we do that, we can just draw all of these arcs now. The top arc, that's going to be something like this, right? So that's going to be right like that. And the bottom one, that's going to be like that. And the two side arcs, right, those are going to look something like this. And so if we connect the lines, they're going to look something like this, right, and like this, and like this. So now we can see that we have 4 different arcs, 4 different like fan-shaped things, like that, right? And we have to get those, so we have to get these parts of a circle areas, plus we have to get this triangle and this triangle and this triangle and this triangle. Then we have to add everything up all together, right? And so first let's tackle the arc parts. Let's make this orange right here. For this one, for this one we can see that it's a quarter circle quickly. So this is a quarter circle and it has radius of root 6. And that's because we can look at this right triangle over here. This is root 3, this is root 3, and this is right. That means this must be root 6, right? So the radius is root 6. And so the area is pi times root 6 squared, that's 6, times this is a quarter circle, so it's 1 over 4. This is 3 over 2 pi. So 3 over 2 pi is our answer here. And next, let's look at both of these. Let's look at both of these yellow, not exactly quarter circles. And so for these angles, for these angles, we can notice that, this is 1, right? Because this is 1. So this is 1, and this is root 3, so this is also root 3, right? This is root 3, and this is a right angle, so it's 1 root 3 and a right angle. That means that this much is 2. So that gives us that our radius is 2, like that. And for the angle, we just saw that this was a 30-69 triangle. That means this is 30 degrees. Same for here, this is also 30 degrees. That means the whole thing, this is 60 degrees. Same holds for over here, it's 60 degrees, right? So that's going to be, radius is 2, and this is in total 120 degrees, so that's 1/3 of the circle, 1/3 of the circle. So that's going to be 1 over 3 times 2 squared pi, 1 over 3 times 2 squared pi, this is going to be 4 over 3 pi. So we have 4 over 3 pi like that. And lastly, we have still more to go. Anyways, this is our last part of the circle, right? And so from this, we can see that since this is a right triangle, this length is root 2, so the radius is root 2. Radius is root 2, and it's a quarter circle, so area is going to be pi times root 2 squared, that's 2, times 1 over 4. This is 1 over 2 pi, right? So this is 1 over 2 pi. And finally, we can look at these triangles, right? We can look at these triangles, and we notice that they are symmetrical about this. So if we just get these things and then multiply them by 2, then we get our answer, right? And then we know now that this is root 3, right? So this is root 3, and since this and this are equal, that means this is also 1, right? So this is root 3, and this is 1. Yeah, that's 1. That means that this much is root 3 minus 1. So that's root 3 minus 1, and this much, that is just root 3. And so we know that this triangle, that is going to be 1/2 times root 3 minus 1 times root 3, right? And so we have 2 of these, so we just multiply that by 2, and that just means these 2 are going to cancel out. So that's root 3 times root 3 minus 1, that's 3 minus root 3. So that's just for the top part. So this is going to be 3 minus root 3. And for the bottom part, we just do the same thing. We note that this is root 3 and this is 1, so that must mean this. Yeah, so that must mean this is going to be the root 3 minus 1. And this is equal to 1, and so this is root 3 minus 1 times 1. That gives us that this is just 1/2 times root 3 minus 1 times 1, right? And we have 2 of these, same thing. We just cancel out that 2 because we multiply that by 2. And so this is just going to be root 3 minus 1. So this is going to be root 3 minus 1. And so if we add these 2 together, then that's going to be 2. And so this whole thing is going to be 2. And so what we do now is we add all of these together. That's just going to be 3 over 2 pi plus 4 over 3 pi plus 1/2 pi plus 2. That equals 10 over 3 pi plus 2, which is equal to 10 pi plus 6 over 3. So it's going to be 3 plus 10 plus 6. That's going to equal 19. And there's our answer. It's C. Number 24. 3 distinct segments are chosen at random among the segments whose endpoints are the vertices of a regular 12-gon. What is the probability that the lengths of these 3 segments are the 3 side lengths of a triangle with positive area? Okay, so first if we draw half of this 12-gon, and that's going to look something like this, right? So this is half of the 12-gon, so we have 6 sides, and these have to be the vertices of a regular 12-gon. So if we draw the diagonals, then that's going to look something like this, and then we're going to have diagonal like this, and then we're going to have a diagonal like that, and something like that, and something like this, right? And finally we will have the length from here to over there, right? So that's going to be our final diagonal. So let's just label all of them as A, B, C, D, E, and F, like that, right? So these are the diagonals of the 12-gon. And then if we count the number of these, then we can have 12 each of A to E, but we just have 6 of F. So this gives us a total of 12 times 5 plus 6. That is going to be equal to 66. Yeah, so that's the total number of diagonals. So for the total number of triangles that we can make, that's just going to be 66 choose 3. Sorry, that's just, choosing 3 out of those 66 to make a triangle. And so now, let's get to the parts where we can actually make a triangle. And so to do that, we will just compare the lengths of A, B, C, D, E, and F. Obviously, A is the smallest, and then we have B, C, D, E, F. And let's say that F is equal to 2. Since that's the diameter, let's just set that equal to 2. If F is 2, then notice that C here and C here, that's just going to make a right triangle, an isosceles right triangle. So that means C must be root 2. So C is root 2. And also notice that if we put B right here, like that, then this is going to be a right angle. And since this and this angle is equal, that means this is going to be 30 degrees and this is going to be 60 degrees. That means it's a 30, 60, 90 triangle. That means if this is 2, then this is 1 and this is root 3, right? So that gives us that B is 1 and D is root 3. And A and E, we could do that with like this sine of 15 degrees, 75 degrees, like that, but we don't have to do that here. Now we can just see the number of times where it fails. So the number of fails, so it cannot make triangle. That's just going to be the parts when it cannot satisfy the triangle inequality. So first of all, let's not consider A. So first, if we don't consider A, then from B, C, D, E, F, the only fail that we're going to have is choosing 2 B's and 1 F. So choosing 2 B's and 1 F, that's going to be a definite fail, but nothing else from B, C, D, E, and F is going to fail. So B, B, F, that fails, but nothing else. And now let's take A into account now. If we have A, A, B, but then that's just given. That's just A, A, B. That's obviously making a triangle, so that holds true. But then what about A, A, C, right? A, A, C. So we have A here, and we have A here and C here, and obviously we see that they won't be able to reach. And so that gives us that AAC is also impossible. But then since D, E, and F, they are longer than C, then if they are impossible with C, then of course they are impossible with A and A, right? So C, D, E, F. So C to F, that's all impossible. Then let's try A and B. A, B, C. A and B and C, that's possible because just this is B, so ABC, that's a triangle right there. And what about ABD, right? That means A is going to be here, B is going to be like that. So B is going to be like that, A is going to be like here, and D is going to be this thing, and they don't reach, right? And so A, B, and then D, E, F, they all don't reach, right? D to F. And now let's look at AC. A and C, that would just be equal to this one and this one right here. So ACD, that's obviously possible. But we have A like here and C right there. If we have C like that and A like that and E like that, then this is going to barely meet, right? So we notice that C right here and A right here, that is going to like barely meet on this E, right? So that is going to meet. So that is still impossible, right? So that's A, C, and then E to F, that's impossible. But for lastly, we have A, E, and F. But we know that this A, E, and F, that just makes a triangle. And so that's possible. And so these are all the things that we have to take into account. And so this just means that BBF, that's just, we have 12, choose 2, right? So choose 2 of the B's and choose 6 F's. And then we have 6 F's, right? This is going to be A choose 2, so 12 choose 2, so 2 A's, and then C to F, we have 12 C's, 12 D's, 12 E's, and 6 F's. So if we add those together, that's going to be 42, right? So times 42, and that is going to be A and B. Those are 12 separate things, so it's 12 squared times D to F. D, E, and F, this is 12, 12, 6, so that gives us 30. And A, C, E, and F, so it's A is 12, C is 12, so it's 12 squared times E to F, that's just 12 plus 6, that's 18, right? So 18, and if we add all these together, then this is going to be equal to 12 choose 2 times 48, that's just grouping these together, and then plus this much, that's going to be 12 squared times 48. So this is going to be 48 times 12 choose 2 plus 12 squared. So this is going to be equal to 48 times, this is going to be 6 times 11 plus 6 times 24. That's just 6 times 35. So it's 48 times 6 times 35. So this is the number of fails. And so for the fails, that's going to be 48 times 6 times 35 over 66 choose 3, which is basically 66 times 65 times 64 divided by 6. So that just makes this one 11. So if we cancel, then this is going to give us 3, and then this is going to leave us with 4. This gives us 2 and 3, and 35. That's going to give 7, and this is going to give 13. Right, so this is all going to be 3 times 3 times 7. That's 3 times 3 times 7 over 11 times 13 times 2. That's just 63 over 286, right? But this is the number of fails, and so to get the number of the things that are actually possible, we have to do 1 minus that. So 1 minus 63 over 286, that is equal to 223. Yeah, that is equal to 223 over 286. And that is our answer. It's E. Last problem, number 25. Let FC to C be defined by FZ equals Z squared plus IZ plus 1. How many complex numbers Z are there such that this is greater than 0? Okay, so what this means that this is the imaginary part of Z. So the imaginary part of Z has to be greater than 0, right? And both the real and the imaginary parts of FZ are integers with absolute value at most 10. Okay, so first of all, let's think when Z is a real number. When Z is real, then that's going to give us, this is going to be the real part, and this is going to be the imaginary part. So FZ, this is going to be Z squared plus 1 and plus ZI. So if we have a real and imaginary, this is going to be Z squared plus 1 comma Z. And so we can think of this as like x comma y coordinate, right? So this is basically going to be the graph of y equals x squared, that's going to be the graph of x equals y squared plus 1. If we draw our axes, right, and so if we draw it like this is the one that we put in, right, so this is what we put in, and so that's our input, and this is our output. So this is our input, and this is our output. We have the real and imaginary axes, real and imaginary axis. This is the complex plane. Then this is going to come out when we put in real values of z. So if we put in real values of z, that's going to look like this, right? So real axes, that's going to look something like this. So that's going to be a parabola that looks like that. We're going to be centered right there, and that's going to be our parabola. And next, right, so this is that. And if z is purely imaginary, right? If z is purely imaginary, then that's going to give us fz. This is equal to this, but that's just going to be z plus I over 2 squared. This is 2, not a z, squared, and then plus 5 over 4, because that's just equal to this thing. And what this gives us is that if z is pure imaginary, then this is going to be something I, and the something I squared is always going to be a negative number, right? And so it's always a negative number plus 5 over 4. So that means it's a negative real number plus 5 over 4, which means that it's on the real axis, so it's all real, but it's going to be maximum of 5 over 4, right? So if we put in everything in the imaginary axis, then we're going to get all the values in the real axes, but then we have to stop right here at 5 over 4. So this is going to be 5 over 4, 5 over 4, like that. And so this is going to be what comes out when we put in imaginary numbers. So we see that this is the maximum. So we get the maximum when z is equal to minus I over 2. This is like this point, minus I over 2. This is minus 1/2 because it's on the imaginary axis. If something's imaginary part is minus 1 over 2, then the result is that so the result is a real number that's more than 5 over 4. If we graph that, then that's going to look something like this, right? So this is going to be the line when it's minus 1 over 2, and that's going to be from 5 over 4 onwards, like that. So from this, we can see that 1 over 2 over or under the imaginary part, this is going to give the green line. So this is going to be within green line, within the parabola. So that means that this much over, that's just this much right here. This much under, that's just this much right here, right? And we can do the symmetry because it's 1/2 over or under. So if we have this line, yeah, then all the points within here, that's going to be between this line, right? So that's going to be in that parabola. Yeah, so we see that this bottom line, that's going to be negative I. And if it's within minus 1 to 0 of the imaginary axis, like that, then that's going to be all in here. That's going to be within the parabola. That means that over 0, then it's everything else. And under 0, that's also going to give everything else. But then let's just focus on this part, right? I have new color pink now. When it's over 0, it's everything else. And we are only counting the things when it's over 0, because the imaginary part of z has to be a positive number. And so that's going to be this part over here. This is going to be what we're putting in. And that's going to give us everything else, right? So that's basically everything else right here and like that, right? So this part is going to basically be this pink part in the output over here. Yeah, so what the problem is asking us is how many complex numbers are there such that imaginary z is greater than 0, and both the real and the imaginary parts of fz are integers with absolute value at most 10. Okay, so this is basically saying that, I'll just draw this line here. So it's basically saying that we have to see, it's saying that we have to see how many lattice points from minus 10, minus 10 to 10, 10, right? So that's basically in this square, right? So that's not a good square, but this is the square it's talking about. This is minus 10, right? So this is minus 10 and 10 and 10 and minus 10, right? Because it said that absolute value has to be at most 10, and that's both for the real and imaginary parts. So this is just, let's say it's a 21 by 21 grid, 21 by 21 grid, because we have 10, minus 10, and then 0 at the middle. That's why it's 21. And then our part of the pink part, right? So our part of this pink part, we have to find that this is going to be equal to the 21 by 21 minus points that are part of the yellow part, right here. So if we get this whole thing and we subtract the points here, then that's going to give us the number of points inside here, right? And so that's basically what we're going to do. So this is going to be 441, that's 21 times 21, minus, and then we have to see how many points are inside there, right? So looking at this, we see that right here, this would just give us 10 points, right? Because this is just 10, 0, and because that's just 10, so this would give us 10 points, right? So 10 points. And then when this is 1, so when the imaginary part is 1, so this is basically just x equals y squared plus 1. And so if y is 1, then x is going to be starting from 2, right? So y is going to be starting from 2. So 2 all the way to 10. So 2 to 10, that's 9 numbers, right? So that's 9 numbers, that's 2 to 10. And then if y is 2, then it's going to be from 5. So 5 to 10, that's going to be that's going to be 6 numbers. And if y is 3, then it's just going to be from 9 to 10, that's going to be 1 number, right? And so we have 1, 6, 9, 10, and the same thing downwards, so 9, 6, and 1. And so if we add all this together, so it's 1 plus 6 plus 9 plus 10 plus 1 plus 6 plus 9. That's just going to be equal to, this times 2 plus 10. This is going to be 10 plus 16 times 2, that's 32, that's 42, right? So we have 42. This is going to be 441 minus 42, which is 399. So this is going to be your final answer, and it's A. So that was it for the AMC 12A from the year 2013, and thank you for watching.